All right. So a bit about myself. I'm essentially a hacker, a modem hacker from the 80s. I grew up with a keyboard in my mouth, between my teeth, instead of a knife. Growing up in a rough neighborhood, namely Israel. Israel is all about the security mindset from an early age, so it doesn't matter if you apply it wherever you do, it's everywhere you are handling it. I'm also a part of a group called Tenroot, which is a cybersecurity company, services company based in Israel. I'm having a lot of fun with technology for a bit over 30 years. With code, with IT security, with different types of systems from VMS, open VMS, mainframes that Win mentioned, and of course, obviously, through Microsoft in the last 2.5 decades almost. And the thing I'm going to talk about today, Active Directory, or Hacktive Directory as I like to call it. It's actually, Hacktive Directory is a phrase I coined back when I was part of Javelin Networks. Javelin Networks is a startup that was founded by ex-Israeli Air Force and Intelligence Corps officers that we sold to Symantec. It's a deception solution for Active Directory. We sold it to them in 2018. But that's a technology I feel very comfortable about. And today I'm going to talk quite a lot about Active Directory. Other than that, I love to enjoy other things in life, like flying planes, volunteering to all kinds of populations, and playing music. I actually played here in Hellfest. If there are any metal fans here, I played in Hellfest a few times. Yeah, I played, I know very well Gojira and all the other guys. So a lot of respect for friends, not only in hacking, excellent talent, but also in music. So we'll talk about Active Directory, why it's so hackable, why is Active Directory making so much noise and problems in its third decade of life. We'll speak about how we investigate incidents in Active Directory, even if we have no logs, we don't have any auditing, no SIEM, all the domain controller was wiped or encrypted, how we can understand who did what, using very specific files. And finally, I'm going to release today, officially announce a tool to detect pass the hash and golden tickets on endpoints on GitHub. So Active Directory, for those of you that are not too familiar about it, who here runs Active Directory or is logging into an Active Directory every morning? Obviously, almost the entire audience. I think apart from the SO, it's all Fortune 500, except one company, it's 95% of the organizations in the world run Active Directory. I think it worked to Microsoft more than they planned. It's a very popular centralized management identity repository. All the users, passwords, computers, access control, etc. are there. But there is a population that really loves Active Directory more than sysadmins, and this is hackers. Active Directory is a pivotal part in every major hack that is done. And like I said, even in its third decade, it's still trending. It's in the top trending for identity, and all kinds of APT groups use it all the time. Nation-state level attackers are targeting Active Directory. And this really begs the question, why is Active Directory so hackable? For me, it's a bit like TCP/IP. You see, TCP/IP is a great success, very popular, but it was never meant or designed to do anything close to what we do with it today. It's sort of, all the packet switching thing was sort of an experiment, but back in the days, spoofing, non-repudiation, all the things that we fight today as patches on TCP/IP as an architecture and as a solution, they were never in the design goals, in the mindset of the designers of the IP suite and the protocols. The same is with Active Directory. When Active Directory was planned and designed in the early 90s, of course, they put MIT version 5 Kerberos and DNS and other technologies, but there was no storage, EMC, NetApp, the things that we know today, no virtualization. VMware was still not around, not to mention cloud, SAML, web services, JSON. All these were things in the future, and not to mention all types of attacks that we see today. That's why it's involved in every huge breach, and it's not going anyway. So people think because of the cloud and Azure that Active Directory will disappear. It's happening very gradually that the workloads are transferring to the cloud, but most organizations will stay hybrid for many, many more years to come, and many organizations will have workloads never leaving the on-prem AD. And compromising your Active Directory means game over. And why is Active Directory so hard to defend? Well, one of the main issues is the lack of knowledge and in-depth skills when it comes to how Active Directory really works. And I've outlined here a number of things that if you really want to get your grasp well around Active Directory, you should really feel very comfortable about all of these concepts. Meaning, not to mention, I'll go very briefly, but authentication protocols. Many people kind of miss out that Active Directory can authenticate in 3 different protocols, including LDAP and LDAP-S, meaning LDAP over TLS. By default, LDAP is an authentication protocol which is unencrypted in your network, and you can see secrets there. People miss out that certificate authentication is part of AD, and certificate enrollment is vulnerable. People miss out sometimes the fact that security principles, essentially objects that have security identifiers, SID, are not only users and groups, but also computers, which are accounts. Computers can log in and perform actions just like users. They're really users to any means and a name. Also, in terms of authorization, when we speak about access control lists and security descriptors, that's really what should be in your mind rather than group membership. And of course, all the things that you normally call Windows internals, I really encourage people that even if you do sysadmin or SecOps work, to really know how processes work and behave in Windows. I'll give you 2 very brief examples why it's hard for people to get their grasp around AD security and why hackers win, why they hack you all the time so successfully. For example, in this very basic video that I recorded, there is a user called Laura. As you saw in the GUI, in the UI, and I will also show you here in the built-in command line, it only is a member only of 2 groups, right? Domain users, which is the default group, the primary group, and marketing. Is it really? When she will log into the domain, what do you think will be her effective token, the group membership that will really be part of our token? So here is a script I wrote. It's up on my GitHub. You can download it now. Very simple implementation of enumerating the Kerberos token group. And you can see that when she will log on to the domain, she will have also managers and development. 2 more groups that will be part of the token that she will present to the network and to permissions. And when you look at it, so you don't see any evidence directly, but the thing is those come from cumulative nested groups. So when we will look on the member of attributes, when we will just double click on one of them, you will see that at some level in the tree, she has also other groups in her token. That's how they got here. And you can actually do this enumeration to any user, including your administrator. Anyone can do it in the organization. Another example for backdooring Active Directory, to have a backdoor, is admin as the holder. Look at this user, simple user named Kai, and you will see he's not a member of any group, right? So essentially just the domain users. This is the default user that everyone belongs to by default. The domain controller in this case is lon DC1. Obviously, I cannot access the C$ drive over the DC because I'm a very simple user, right? The simple that you can get, very, very far from being privileged. But still, you can see that with this logged on user, Kai, I will now go to, for example, enterprise admin. Enterprise admin, as you know, the forest administrators, it's a very high privileged group in the entire forest, not only in your domain. It can have effect. And administrator is the only member of it at the moment. And I'm going to add arbitrarily whoever I want. I'm going to add Ashley, just a simple user named Ashley. And it works. So I don't have any permission in the network, and I am not a member of any group, and I was able to somehow add any user I want to any group I want in the domain. So the trick here, if you will go and see the permissions on enterprise admins and you will remove it, in less than 1 hour, it will come back, because there is a very simple mechanism called admin SD holder, the administrative security descriptor holder or placeholder of permissions that get propagated again and again on privileged objects. And if you will not check for this, and if you are a member of a blue team or you have a SOC or whatever, I bet you're not checking this right now. Is anyone checking admin SD holder permissions on their AD? This is okay, there are a few. That's very well for you. But most people don't. Most products don't. And that's a mindset thing. That's one example out of hundreds that you should look for in AD. So Active Directory is exposed by design. Not only every endpoint trusts it, any authenticated user, but also trusts it in dozens of protocols and APIs. LDAP, Kerberos, DNS, WMI, RPC, DCOM, OLEDB, ADSI, System Directory Services, AD Web Services. And if you look at even the ports on an Active Directory, keep in mind, there is no single port for Active Directory. You have to protect all those ports, especially the yellow one, which are mandatory, obviously also the blue one. At least from certain workstations, the Active Directory PowerShell module works with the AD Web Services, and all the ephemeral ports, high ports for the RPC communication, DCOM, WMI, etc. To add on top of that, Microsoft has made it very confusing to design your AD infrastructure securely. I know I've worked for Microsoft for nearly a decade, from late 90s to 2007. Feeling like the only security guy back then. It's really amazing what this company has done in the security push. But the recommendations change every 2-3 years. So in the last 20 years, Microsoft recommendation has changed like 5 times, from consolidating domains to making sure you understand that domain is not a security boundary, and then giving you the Red Forest model, which doesn't play well with the cloud, and then giving you the admin tier model, which kind of survived quite well until today, and today speaking about privileged access. Obviously, organizations cannot restructure their entire IT infrastructure every 2-3 years. And it's nice that the recommendations change, but that's also confusing. And the final piece of the puzzle is the users. Of course, users are behaving like addicts. You can speak to them until tomorrow about really good secure options in the platform, but then they will go to the normal, less secure options. So that's about Active Directory in general. And now we're going to step into the forensic part of things, because there are many forensic tools and talks and concepts and skills going around with memory acquisition, memory dumps, images, things to do with the disk, etc., but less about Active Directory. And Active Directory, like we said, is a very crucial, pivotal element of every breach in your organization. Very hard to do reconnaissance, lateral movement, privilege escalation through AD as a platform. And what can you do when Active Directory gets hit in a ransom or any other type, a wiper, a malware, etc.? So the possible scenario we look at hand, and I was unluckily or luckily to testify in dozens of those type of events. Sometimes you'll have no logs. Either they're not collected, not audited, or they were wiped totally. The DCs are totally encrypted, offline. Maybe you get a good backup, like a recent backup, quite close to when the event happened. But still you want to build a timeline. Who did what and when in your organization? And of course, you can go to the sources of truth in Active Directory, which split to 3 different parts as a bunch of files. Sysvol is namely one of the most common of them, but not the only one. The event tracing for Windows, essentially the event logs. But as you very well know, there are a few types of attacks that can bypass the event logs of Windows, DC Sync, DC Shadow, to name a few. And of course, event logs can be tampered with or deleted, wiped, encrypted, and pickups. But to use a sensor that runs a pickup and responds in real time to every type of traffic, that's something quite challenging. So we are left with a file, ntds-dit, the directory information tree. Essentially, it's the database of Active Directory. And inside that database, we have this thing called the replication property metadata. So what can we do with that file? So the database file of Active Directory, it works in a very specific way. It's a JetBlue database, an ESC, extensible storage engine, quite like Exchange, Wins, and all other. It's a sort of, in the original, it's like the database of Access, Microsoft Access. Access is the I am your father of Active Directory database from the 90s. And it is normally managed by NTDS util. A bunch of tools, but this is the major one to take a snapshot or install a file from media option. This is the utility you can use to get a copy of it. And inside the database, you have all the objects, all the attributes, the properties, the class, the schema. And on every property you have, every time there is a change and a replication is triggered to duplicate those changes between domain controllers, it is written to a property called MSDS replication, either attribute metadata or REPL value data, metadata. It depends if the attribute is single or multi-valued. So group membership obviously is a vector, it's multi-valued. Other properties can be in the MSDS attribute metadata. But you would ask yourself, where is this attribute sitting? So we can use the built-in PowerShell commands and look for this MSDS whatever. And as you will see, it's not part of the properties that get returned. And I asked for all the properties, right? Asterisk. But if you will look, you will ask specifically, you will tell the service to bring you specifically REPL property metadata, you will get bytes. Okay, so we'll see this property actually is in the database, right? We're not playing games here. And if I will ask specifically MSDS-REPL attribute metadata, et voilà. Now you will see XML. Pourquoi XML et non JSON? Parce que JSON did not exist when Active Directory was invented. XML is not the prettiest thing, but wouldn't it be nice if we had a tool that you can run and it would bring you all the changes that your Active Directory had since the beginning of time, since the domain was born, even before your time that you came to the company, all the adding, removing of groups, and maybe all the changes in general, even if you got all the data wiped or whatever. So that's the idea. So we're going to see a short scenario. I'm going to first search for interesting strings in your Active Directory, some IP addresses, passwords, if I find any, basic reconnaissance. Then we're going to find some renamed accounts that will help us in this investigation. Then discover that we have no logs, we have everything wiped, and we're not collecting anything. And then AD replication will come to the rescue. So we have a scenario in which we are investigating that a user named Annette performed some malicious activity. We got an alert from the EDR, and we want to investigate it, but we cannot find a user named Annette. First thing to check is maybe there was a user and it was deleted. For that, you have to enable in advance the AD optional feature of recycle bin, right? So in Active Directory, you have a recycle bin, and you can search for deleted objects there. But the first script I want to show you, all these scripts are available on my GitHub page. You can actually look for very specific string. In this case, I searched for 90210, and I find this match. It's actually a file timestamp, file format signature of the password last set of some attribute. So not really helpful. If I will search for the string Annette, and I will ask to see the match details, so you see I found actually her name somewhere. So at one property. So obviously a user named Annette was a member of that domain. Now I'm going to look for renamed accounts, renamed users. And in this case, because when we have events 4781 on the domain controllers, we can see when there are account renaming happening to the same account name, to the login name. And we can actually see that Annette was renamed somehow, for some reason, to Jane D, this Jane Doe. So now this is also how it will look like in the GUI if you're not using the script, the code, the automated approach. So you will see this event occurring, this 4781 event. So now we know that we have in our investigation to focus on a different user named Jane D. And the next script is the replication metadata history. This actually it works also offline and online. So you can also work with an online domain controller and an offline backup. It will show you all the changes for any object in the domain since the time it was created. So you can see this user, Annette, now called Jane D, was created somewhere in October 2016. You can see it was created from a sort of automated process because many attributes were populated at the same minute, the same time, including the company, etc. And also interesting is that if you can notice, the admin count attribute value was changed somewhere in 2020, July 2020, to 1. And as you perfectly know, admin count equals 1 means that it was a member, or still is a member, of a privileged group. And more interestingly, the most interesting evidence here is seed history. Seed history was populated last March, in March 21, to a seed that ends with a relative ID of 500. 500 obviously is the administrator, the privileged user in any domain, and this really gives us the feeling that there's something wrong with this user, that it was used to backdoor from a migrated domain. Now we're going to run the next tool, which is get AD group changes. Yet another open source PowerShell tool that you can download and use. And this tool, you can query specific user, any specific group, or any group. Now, this tool will show us very easily and quickly, without messing with XMLs, that Annette Jane D was actually added and removed from the backup operators group. The last action was removed. This change happened when I shoot this video was 9 days ago. And we begin to understand what we are facing here. And keep in mind, this will all those tools will work even if we don't have any active domain controller. I will show you soon with an offline version. Now I asked, using the same script, get AD group changes. Using the same free tool, I asked for all the changes in domain admins, right? Quite a common group. And in this group, I can see that there is a user called Terry. He was removed. The last action was that he was removed from domain admins. We can see the date it was removed, the date it was added, and the days since the last change. And we can also see, interestingly enough, that the member admin count was cleared. Now, this means that either the system administrator, like in a good intention, removed this attribute after something happened, or maybe it's an attacker that after he added himself to a group, he took himself out of the group and actually deleted this member of admin count equals 1. And we can also obviously look at these changes on a user-specific view. So here I query all the changes just for Terry, and I see he's a member of development team. So all he did in his life cycle is just being a member of a development team, and then suddenly he was a domain admin for maybe a couple of hours or something like that. Now I'm going to leave my VM. Here you see there is an active domain, and I work directly with LDAP protocol using those tools. But now I'm going outside to a workstation. Outside of the domain, I'm working totally offline. You can see that my host is not connected to a domain, and I have an offline file that I want to use. So I have here an offline snapshot, essentially a backup of the NTDS DIT, the directory information tree, the database of Active Directory. I don't need the registry. I need the registry just for the decryption of NTLM hashes, etc. But for this tool, I just need the NTDS DIT in a shutdown successfully mode, that it had a clean shutdown. So make sure you get that. So now I'm going to run the tool with an offline database backup. Right? So first of all, I'm going to look for a specific user named Adam. I'm going to use the offline database backup option, give it a path to a database. And what this tool does is on your workstation, it will actually load the database in memory, essentially create an ad hoc in-memory LDAP server that you can query your backup instance live for forensic information as if it was your domain controller. And you can actually use these options this option. Also in the previous script you saw earlier in this video of all the changes, the replication metadata in full, not only the group changes. So we continue to use now, I chose the option to keep the database instance running. So I'm going to use the existing offline database instance in memory just to save a few seconds. And now I'm dumping directly from memory offline, using this offline database, all the group changes since the beginning of this domain. And you see there is options to export this to a CSV, obviously, or to a easy grid that you can work with PowerShell. And this grid is filtered. So now we can see all the changes that happened since the inception of the domain. Very easy to work with that. Before this tool, there was quite a nice tool, actually a French tool called AD Timeline. There still is, that really makes also a nice work on getting all those changes. But this really has a very specific visibility, and extract all these is a very similar, a very useful way that you can actually investigate. So the forensic scripts for Active Directory, get ID changes, replication meta, etc. You can get them now from GitHub. They're there for a while. No special permissions. Anyone can run them. Unfortunately, anyone can run them. So anyone can do it in your organization, even now as we are speaking. No agent. It doesn't install anything. And there are no dependencies, right? No external modules, etc. Let's move to speak about some of the major problems in Active Directory, which are the persistence with the high privileged user compromise in Active Directory, namely pass the hash and most effectively golden tickets. Probably many of you heard the term golden ticket. It's quite scary because we all know that when an attacker has a golden ticket, it has a very strong, persistent hold of your domain. So it can impersonate any user without knowing its password for any period of length of time until you do a password enrollment, until you reset the password of KERB-TGT, the master Kerberos password. So when you have golden ticket, using the KERB-TGT hash, of course. So this can be obtained in multiple ways, right? The KERB-TGT hash, either DC sync, etc., unauthorized AD replication with Mimikatz and other tools, either by a copy of the AD database. Many times you might be surprised, but in the pen tests, the red teams that we have, we find it in all kinds of dollar hidden shares, backup shares in the network, etc. Or it can also be stolen from memory, less efficient in read-write domain controllers, but still, when you get to the domain controller, it's a game over, but you can actually also extract the KERB-TGT. Most known one is the unauthorized AD replication, that you can target all kinds of service accounts, connector accounts, ADFS, SharePoint, Azure AD Connect, etc. And use configurations, misconfigurations with excessive permissions to get to them. But this attack can happen in multiple ways. They can happen with RC4 and for a long period of time. They can happen with AES 256-bit encryption in the hash. And they can look like a duck, walk like a duck, behave like a duck. So they look very convincing. But still, there are unsimilarities when you really look into those tickets in depth in the memory of the endpoint. So to discover a golden ticket attack from the domain controller centrally, you need to have very specific products, commercial, and you have to collect you have to know all the TGTs that the domain controller has generated. But today, I'm announcing Goldfinger. It's essentially yet another open source tool that I just released to GitHub. What this tool does, it goes out and collects, analyzes, and hunts for suspicious TDTs. So it looks for golden ticket and pass the hash proactively in real time in all the domain joined endpoints. So it doesn't need any agents. It works with either WinRM when it's enabled, PowerShell remoting, or SMB. It uses behind the scenes PA-exec, the open and non-commercial version of PS-exec with the admin dollar share. It has no dependency or external modules. It's just a text file, two text files that you copy and run. there was a lot of research done to detect multiple anomalies with the low to high suspicious to any detection there. It does require, however, to be a local admin at the endpoints. Unlike the forensic tools that I spoke about earlier, this tool has to enumerate with the system token all the Kerberos sessions. Essentially, it runs k-list sessions and enumerates and analyzes, parses all the Kerberos tickets in all the endpoints on the domain. So it supports, by the way, running on different domains, also other domains, not only the currently logged on one. It supports running on all computers or just workstations or a specific computer or computers, or you can exclude specific computers, can optionally enable WinRM. On the way, if I discover a machine has a clock skew, you know in Kerberos, if you have more than 5 minutes clock difference with domain controller, you get RPC not available and all kinds of connectivity issues, so I fix it on the way if I encounter that on the script and more. Obviously, we are all on the shoulder of giants and as a community. So the collector part, I heavily used previous work by Jared Atkinson and Matthew Graeber, two very cool and amazing colleagues that have done a great job there. So I don't have to reinvent the wheel on the k-list session kind of thing. So let's see that in action. So in this sample domain, I have 3 VMs, virtual machines I'm going to work with, the domain controller and another 2. I'm going, first of all, to just run the tool with the default options, just not to put any parameters. So as you can see, Goldfinger is run. It found 3 potential computer accounts, enabled computer accounts, but only 2 machines were available in terms of connectivity in WinRM, and it collected 10 TGTs, 10 ticket granting tickets, Kerberos authentication tickets, but it didn't find any anomalies. So first thing to notice about Goldfinger, about this tool, it's essentially a TGT collector, right? So you can also use it even if, on the day-to-day, not in an incident response or if you have an investigation. If you just want to know who authenticated from where and when, essentially. So you can just collect Kerberos tickets from the endpoints. And you will get all the endpoints, and you will see all the Kerberos active authentication Kerberos sessions from all the machines. But that's not what we want from that tool, right? Let's try to hunt for a real potentially malicious activity, pass the hash. Now, pass the hash, we're going to one of the machines here, the Lone CL1, this Windows 10 machine, and we're going to run Mimikatz, obviously. Big pride, yeah, French pride, Benjamin and Vincent Letou and all the great folks. French is very good in computer hacking, huh? J'adore. And I'm going to pre-prepare this command. And as you can see, this is pass the hash. So pass the hash, essentially, I am running the process with user Adam. This is the primary token, the process owner. But when I go to the network, I'm using the impersonation token. So in the impersonation token, I am administrator. But in the primary process token, I am a different user. This is essentially what it means to have a pass the hash. D'accord? Very simple. So now I could also impersonate it in other ways, but I wanted to have a real pass the hash. Now I'm going to run the script again with the same options, but now you will see the tree will light in the house. So now we have we have a warning. You can see that we found suspicious Kerberos tickets with high suspicion. You see all the parameters, the properties of that ticket, and you can also see in the beginning if you saw the anomaly that it detected, why it was flagged as a suspicious ticket in the domain. You obviously get the name of the workstation, and you get a CSV, so you have a separate CSV for the suspicious tickets and a separate CSV for tutle tickets that you picked up. Now we're going to try a golden ticket on this scenario. So we're going back to the same machine, Lone CL1. And on that machine, I also pre-prepared the default and useful syntax for golden tickets. This syntax creates the default golden ticket. I also added other special groups but essentially made a golden ticket right now, right? And I used the PTT option, pass the ticket, so it injects the administrator ticket directly in memory. Alors now we have a golden ticket in memory on this machine. This time we're going to run the script again, but just to have some sense, we're going to run it with the collection method of SMB. The SMB collection method is a bit slower because essentially it is slower to initiate an SMB session rather than an HTTP WinRM session. But you will see once it's finishing, we have a second ticket. This one has different anomalies. You will see that this ticket also has a high suspicion, but when you will look at the report or the grid that popped up, you will see that this ticket has much more multiple anomalies. So the default syntax of Mimikatz that you see on the internet that people use in Kali Linux or Metasploit, etc., that's what it will give you in the minute that you will run this tool. You will see all these anomalies, the time difference in hours, the token size, the Kerberos ticket age, ticket renewal time. You will have a bunch of anomalies. But sometimes attackers are clever. For example, in our red team assessments, when we do use golden tickets, we don't always use that. You have to make some judgments because hacker is first a mindset and then everything else. Then the skill set, the concepts, and only the last is the tools. But now we're going to hunt for an advanced golden ticket. How do you create an advanced golden ticket? Well, you use all the options that make it appear as if it is a very legitimate authentication session. And in our case, yeah, I'm also making the fonts bigger live during the recording. So in our case, I'm going to create a ticket of the administrator user, but it's going to use the AES 250 bits encryption hash, no RC4, and it's going also to use the domain, default domain renewal for 10 hours for the TGT. I'm also going to make it look exactly like an authentication session of the administrator account. So now in this other machine, if you saw, this is Win8 PC, and it looks perfectly normal, right? So it looks quite okay. For many tools, it will look quite okay, especially EDR kind of tools. Now we're going to run it with some other options, so you can see there are other parameters, but we're going to run it on workstations only, and use the verbose option, and get some more logging to the screen. And now you will see we have 3 suspicious tickets detected, and obviously the one in the middle, the Win8-PC, that's the one with the session client mismatch. Session username doesn't match the client. You see that other than that, it looks perfectly normal. It has the logon domain controller, time difference is perfect, the ticket flags are perfect, everything is perfect. Just the client name on the ticket doesn't match the session username. This is enough to understand that either it's a management application that did something very specific here, or, and this could be a potential false positive if it's a management one, but obviously in this case not. This is how a full logging of the run of the tool looks like. It's quite useful when you use SMB, essentially. So you will see it's the credentials you're running, the context, how many potential computers it found, and then it will try to see if it can access them, whether in WinRM or SMB, before actually running the script. Then it will collect the script and analyze them. You will see how many tickets it found for each machine, or if it failed. If you see failed attempts, they will also be here. These are all the tickets it detects. By default, we exclude the computer TGTs, but you can also include them as a parameter, as a flag that you can mention, as a switch, and the total ones discovered. You can also exclude computers, like I told you. You can see it also in the help of the tool, and you can also check for other domains. Keep in mind that there are still potential false positives, right? Because past the hash, essentially, it's just like secondary logon. Many applications all kinds of management applications, etc., use this type, especially from system, spanning system process, system shells, and then having the session user being a system, but the client name is the Active Directory user, because system has full permissions on the machine, but it needs permissions on the domain. So this will generate an alert, but a low suspicious alert now on the tool. We fixed that in the beta. Another issue to be aware of is because we are enumerating all the Kerberos tickets in the endpoints, this type of activity can look a bit malicious to some tools. Some tools can detect that many instances of WinRM are running, so be aware, and you have to whitelist that in advance. Or sometimes even antivirus can detect that as a power view or whatever. In this case, because AMSI discovered Matthew Graeber's functions inside the collector, the one that runs physically on the endpoint. So you have to exclude that in advance in order for that to run. Obviously, I could bypass this alert and do an AMSI bypass before I run the tool, but I'm not here in this case. I'm not here in the head of a red team or a pen tester. I don't want a tool that is used to protect you to bypass your defenses. But that's how it will look like in the log. You will really see this alert that your script was blocked by antivirus software, because I take out all the STD out and STDR, and I can analyze that in real time. All those scripts are up and available on the internet now. You can download them. So key takeaways. Hopefully, you were able to see some really nice forensic artifacts in Active Directory. Many of them are not that obvious to see and to collect, but you have a bunch of tools that you can certainly use. I really encourage you to get the right knowledge. The journey of Active Directory security is really all around a lot of knowledge and understanding many concepts. Just don't go directly after the tools. Understand in depth how this technology works, because even today, like I said, after 25 years, still I encounter many people that don't really understand in deep how Active Directory works. Of course, AD forensic is part of a wider picture. If you have other sources, you have to tie them with the AD forensic information. And check out just either ActiveDirectory.com or GitHub my page for the code and scripts. And with that said, I think we have some time for questions, right? Parfait. Two minutes for question. D'accord. So, any questions about what we discussed? Or you are all in shock? Yes, it's true. Active Directory is very hackable. If that causes you a shock, alors c'est la vie. Well, any questions? Yes, please. Oui. Yeah, s'il vous plaît.
Hello, Betsy. Nice talk. If you have a full history of whatever happened at Active Directory level, you could probably use it for red teaming as well, password changes, things like that.
Yeah, so the question was if we have all the history, and in a free tool, open source, anyone can use it because there are no special permissions. Definitely. Anyone, you have a knife, you can cut a salad, you can stab a person. Technology, it's a tool. You know, we never know how others will use it. So obviously, this is the flip coin of technology. You can use it for bad and worse. This part is up to you. For me, my parents raised me in a way that I'm standing here talking to you and I pay taxes. Maybe if I had a different childhood, I will never be talking to you. I will make much more money and I will be totally anonymous. But it's all about the person using the tool. But yeah, vrai, c'est vraiment, it's about who uses the tool. Any other question? Yeah. Hey, here you have the microphone. Maybe it will be better.
Yeah, I was thinking about the advanced goal ticket. the only thing that make it suspect is the name. Can we produce one that matches the other TGTs?
So the question was about the advanced golden ticket. And the only anomaly that really stands out there is that the client name doesn't match the session username. Luckily for us, Kerberos is very vulnerable in multiple ways. It has been like that. It's a MIT protocol from the 80s, right? Early 90s it was, and Microsoft created its own version. Luckily for us, still there are some basic limits. So for the ticket to be in full integrity, the client name and the session username, they come from two different places. So you will have to spoof the process PID. The primary process holds the session name, and the client name is the AD part. So they come from different parts. This comes from the local authentication security authority, and the ticket is essentially working with Kerberos entities, because even if you will try to do that, once you will use the TGT, because TGT, at the end of the day, is just an invitation to create TGS. D'accord? So when you will use the TGS, ticket granting service, and you will try to access a resource, the integrity will fail. So that's why we can still count on this and detect that. Alors, with that said, merci beaucoup, and enjoy the rest of this wonderful conference.